Hello, welcome back to Cracking the Cryptic, and this is an opportunity to do a puzzle by the Pedaling Pianist today, one of my favourite constructors, and it's got a completely new rule set that I've never seen before. Brilliant grid. I'm really looking forward to having a go at this. It's called Projected Differences. We'll get to that in a moment. Don't forget that in the links under the video you can find the way to our merchandise, like this brilliant water bottle with a knowledge bomb all over it and Cracking the Cryptic on the other side. Just what you need in the hot weather. And then of course there's also Sven's SUDOKU pad in the links under the video, and all of our apps, which are fantastic value and a brilliant way to pass the time. There's of course also the link to Patreon, our Patreon site, where the $2 Patreons get a monthly reward every month and plenty of other content. The $3 a month Patreons get solution videos for that monthly reward, at least, as well. And anybody can visit the site and have a go at the 600,000 subscriber celebration pack, which has got some brilliant puzzles in it, from James Sinclair, Codec, Half-Baked Lunatic, Fistamafel, Piotr V and Garford together, Tall Cat, Olimar, Juggler, and Florian Wertmann. And some of those puzzles are just amazing. Actually, all of them are amazing, but some of them are mind-boggling when you look at them for the first time. Well worth a look. Do check it out. But the first link under the video, as always, is to the puzzle Projected Differences by the Pedaling Pianist. I'm going to go through the rules now and then attempt the puzzle. And the rules are these. Normal Sudoku rules apply. 1 to 9 in every row, every column, and every 3x3 box. Also, we have marked diagonals that each contain the digits 1 to 9 on as well, the blue lines. And we get a given digit, bonus from the Pedaling Pianist, but also a diamond clue shows that there exist 2 digits n steps away. So the diamond cell will contain n. That might be, say, a 3. And a diamond clue shows that there exist 2 digits n steps away from the diamond in an orthogonal direction that have a difference of n. Well, this is a good one to choose. If this was a 3, you can't go 3 cells north or 3 cells east. So the 2 steps, or the 2 projected cells, would be there and there, 3 south and 3 west, and they would have a difference of 3. It's a fascinating idea. Not all diamonds are necessarily given. And the example in the rules actually mentions a 3 there. In that case, then you have to consider all of those cells, and 2 of them at least have a difference of 3. Isn't that weird? From the sets of digits in row 3, column 4, row 6, column 7. Have I missed one? Oh no, I see, I've misread. It's saying, sorry, there's a diamond here. If that was a 3, that's saying that it's though any 2 of those cells have a difference of 3. It doesn't, or it could be multiple pairs. Anyway. That's the rules. It's quite strange. Let's see how this works out. And let's restart the puzzle and try it. Let's get cracking. So, what do you do to get going? I think what you do is you observe that one of these diagonals has 8 diamonds on, the positive diagonal. What's going on there? Right, I've got it. I know what's going on there, and I'm filling in a digit. Bam. Okay, none of those diamonds can contain the number 9, because a diamond says that n steps away there are 2 cells. Now you can't step 9 steps away from any cell. You'd be outside the grid to the south or the west, and miles outside it to the north or east if you started from here. So no diamond in the puzzle at all can have a 9 on. That might be worth knowing. Okay, let's actually use that to say 9 must be in one of those cells, because these can't have a 9 on. I'm pencil marky enough to risk that. Now, okay, the next thing I'm going to say is, where is 8 on this diagonal? Okay, this is good. 8 is either there or there, because they're the only cells on the diagonal which have cells, digits 8 cells away. So one of those two is an 8. I am going to pencil mark that, even though they're not in the same box or even row or column. But the interesting thing about that is they're both referring to the same 2 digits. If you're looking at that, 2 cells that are 8 away have to be those 2, and they're the same 2 for the northeast corner. So those 2 cells that I've just highlighted have a difference of 8, and they must be therefore 1 and 9, and this one up here can't be a 9 because it's got a diamond basically, and because we pencil marked it as such. So that's a 1 and that's a 9. And now this 1 is in a diamond, and that is saying that these 2 cells have a difference of 1. Oh my goodness, I'm going to place the 9 in this box. Right, I'm going to say first of all that this can't be 9 because these 2 cells, let's just green them, they have a difference of 1. That's what that diamond's telling us. And if this was 9, that would have to be 8. But that only has 1 cell in the grid 8 away. It's got a diamond in it, this is my point. And that's there. So there aren't 2 cells that it sees. So that's not a 9. I also know that this isn't a 9 because it's on a diagonal where a 9 now appears. Therefore, this is the 9 in box 1. I don't think I can do much more with those 2 green cells that have a difference of 1. Every diamond in this puzzle is going to count, isn't it? Okay, the next thing I'm going to consider, I can't choose which of those has an 8. Basically, that 1, 9 will fulfill whichever corner on that diagonal has an 8. So I'm going to think about these, well, the whole diagonal in the context of where does 7 go? Because it can't go in these middle 5 cells because they don't see any cells 7 away. Now, if 7 was in a corner, then it would be looking at 2 cells that far apart, and they would either be a 1-8 or a 2-9 combination. If 7 was in a near corner, one of these cells, I'm going to consider this one first of all, then it would be looking at these 2 cells to be either, well, yeah, a 2-9 or a 1-8 combination. Well, this cell can't be 1, 8 or 9. It can't be 1 or 9 because of the box. It can't be 8 for a reason we just discussed. So if that was the 7, this would be a 2, but that would make this a 9, and that's impossible. In fact, the whole point is, right, none of these can be a 7 looking at a 2-9 pair, because 9 is already in both of those corner boxes, boxes 1 and 9, and not in the position it would have to be in. Therefore, 7 is looking at a 1-8 pair. And the 8 is 7 cells away from either one of these or one of these. And that means it's in one of these 2 cells. Isn't that brilliant? That is brilliant. There's either a 7 here or here, looking at what can't be, looking at one of those cells. So it can't be looking at a 1 there. We've established it can't be looking at 2 or 9. So it is looking at 8 in one of them. Now, since we highlighted them, we know that that is an 8-7 pair. And we've established that. Now, it hasn't told us anything about which one of these is a 7, looking at an 8 in one of these cells. But it does mean that the counterpart 1 is in one of these cells. And it also, much more importantly, means we can determine what's in this diamond, because we've worked out twice already in this puzzle that that's not an 8. So that's a 7. And that's an 8. And this diamond is now the focus of our attention. It is looking at those 2 cells. And they can't be 2 and 9 because they're on a diagonal with a 9. So these are 1 and 8. And we've pencil marked 8 on this diagonal as being there or there. So we now know it's here. And that's a 1, and that's not 8 in that corner. And that 1 settles the 1 issue down here. This is gorgeous. Maybe I didn't need to settle that, but I'm settling it. We've got a 1 there. And one of these places was a 7 looking at a 1-8 pair. Well, I still don't know which one it is. They're both looking at both of those cells. So one of those is the 7 on the diagonal. And I mean, I'm tempted to now talk about 6. But I don't know if it will actually help. Well, okay. 6 can't go in these cells because they don't look far enough outside, within the grid. They can't see far enough within the grid. If 6 was here, it would be looking there and there. And it couldn't be looking at 1, 7 or 3, 9 because 1 and 9 are already on this. So it would be looking at 2 there and 8 there. Now, there are alternatives, unfortunately. 6 could be here, looking at those cells, which couldn't have a 1 in either of them. So they're not a 1, 7 pair, and they're not a 9, 3 pair. So again, there'd be a 2, 8 pair. But there is a third alternative for 6, which is here, looking at these 2 cells, which can't be 9, 3 and can't be 1, 7. So wherever 6 is, it's always looking at a 2, 8 pair. And it's either looking from there at that cell, from here at that cell, or from here at that cell into a box where the 2 must be. And I think the counterpart positions are here, here, and here for the 8. Just checking that through. Yes, they are. 8's in one of those cells. Well, it can't be here by Sudoku. So that's not the 8, so this isn't the 6. So that's not the 2, but much more importantly, the 6 is now in one of these 2 cells along with a 7. That is a 6, 7 pair. It's such a strange puzzle. This is intriguing. It's really, really clever. Now, the digits left on the diagonal are 2, 3, 4, and 5. The central one cannot be a 5 because that cell doesn't, that cell can't look 5 cells in any direction at another digit. However, I may have to now give up on this diagonal a bit. Now, I'm just looking now at the given 6 and where 6 is in box 1. It's in one of those 2 cells. If it was there, well, yeah, it would be looking at 1 and 7. That's certainly very feasible. Oh, no, this is not a diamond cell. It wouldn't be looking at anything. I hope I haven't done that wrong already in this puzzle. Looked at a non-diamond cell and treated it as a diamond. I'm not doing it now. I did for a second, but I've cured myself. Now, if 6 was here, it is a diamond cell. It would be looking there, and they would have to be 8 and 2. And that looks very plausible. So I don't think I can place 6. I'm going to pencil mark it in one of those 2 cells. We've also got a 1 in one of those. Now, what am I going to do next? Because I hesitate to say I'm almost beginning to run out of diamonds to use. One of these is a 6, and it's either putting 2 and 8 both on the diagonal. That would be if it was this that was 6, or 2 and 8 there and there. The other one is a 7 and has already established it's 1 and 8. This 1 is done. Oh, let's get rid of the green colouring. Let's actually mark that orange because it's thoroughly complete. So is that 7. We've found its projected differences. We found that 8's projected differences. This 1 we haven't, but all that's saying is that 2 of these are 1 apart. That feels like not a very exciting bit of information. It'll be wonderful if the puzzle turns on that at the end. Okay, we've got an 8 in one of those 2 cells by Sudoku. I don't think Sudoku is going to be the way here. I'm going to have to come up with something a bit cleverer. Or maybe just diagonal Sudoku techniques. I don't know. I don't really know what I'm thinking. So, I mean, I wish I had some clever diagonal techniques to show you. I don't really have anything. This isn't a 1, neither of these are a 1, so I was going to say, so they're not looking north, and that's true, but they could all be small enough numbers to be looking west and east. 6, 2, these are from 3, 4 and 5, that's all that's left for those cells given the pencil marking. These are interesting. What's going on with these cells? I don't know. I don't see how I'm meant to know anything. Oh, there's a 9 to place here. Right, well, it's not in the diamonds, so that's a 9. That's so painfully obvious now. A 9 is not in those diamonds, so one of those is a 9. Then I can place 9 in row 2. There is Sudoku to do in this puzzle. Most helpful. 9 can't be on either of the diagonals in the central box, so it's in one of those positions. That may not be quite as helpful. Now, can you put 8 in these? No, they can't reach west or east for an 8. So now 8 in box 8 is in one of those cells, and that resolves that that's not 8, this is 8. And therefore it's this cell that can now be a 6, with a 2 on the diagonal. And that's done. And that puts a 7 here, which is fully explained as well. That goes orange. And now 6 in box 1 is here in a diamond. And that is looking at this cell and that cell. So this is now a 2, and that is done. Brilliant. Okay, this is a 3, 4, 5 triple in box 1 now. 6, 9, 8. That is 2 or 7. That's 1, 2 or 7. These can't be 7s. In fact, this one can't be a 5 because it can't go east or west for a 5. It can only go north. So I can pencil mark those a bit. This one again, 2, 3, 4 or 5. Now, these don't, we've had the 2 on the positive diagonal. And we're going to have to fit 3, 4 and 5 onto the negative diagonal. Now, we clearly know one of them is there and one of them is there. But the third one can't be here or here because of the 3, 4, 5 group we already have in the centre. So it's here, and these two cells are 7 and 6. And we know the order thanks to the given digit, which for some reason, despite being black, maybe because it's central, I can see today. So we've got a lot of the diagonals done. We've still got 3, 4 and 5 to place. And one of these two is a 5. It's not here because that wouldn't reach. One of them is, it's either a 5 there looking at those two cells, or a 5 there looking at those two. Now, a 5 difference leaves quite a bit of leeway, unfortunately. So maybe that's not what I should be studying at the moment. I don't know. Let's put a Sudoku 2 in there and a 7 in one of those. Right, these can't be 8, and they can't reach left or right if they're 6. So those are also from 3, 4 and 5, which is a triple here, and now I can fill in 8 and 6 in the row. That takes 6 out of that cell. 8 is in one of these two, in fact it's there by Sudoku. And these others, we seem to get a lot of 3, 4, 5 triples lining up. Here's one in the top row, making this group a 2, 6, 9 triple, but we know that that is therefore a naked 2. That can't be 7, that's fairly clear. In this row, what's this? This is not 2. That's not actually very helpful. It still leaves 3, 4, 5 and 7. Right, I am looking for something else I can do. I'm not finding anything at the moment. 6, 9, 2, 8. This can't be a 5 because it can't reach east or west for a 5. If this was a 5, it would be looking at that cell and 1, 2, 3, 4, that cell. This would have to be a 1. That is possible. That's annoying. Okay, hang on. If that was a 4, it would be looking at that cell and that would be a 5. Okay, I'm going to change it up because that didn't really yield much. If that was a 3, by the way, it would be looking at 7, 9 and unknown. But unknown cannot be a 6 or a 4. So there is no 3 difference possible. In fact, in this is a naked 1 in the middle box. And this is a 2, 8, 9 triple. I've only just seen that. 2, that can't be 8. This can't be 1 now. 2, 8, 1, 6, 9. Interesting. I think I've worked out this can't be 3, given the possibilities here, here, and here. There's no 3 difference available between any of those. So I'm taking out the 3. That's not quite what I was hoping to achieve, but let's look at this. If that was a 3, then it does automatically fulfill the requirements because it puts a 4 there by Sudoku and a 1 there. If this was a 4, we've got 2, 8, or 9, 7, and 6. What difference of 4? Yes, 6 and 2 is the only one I can see there, but you only need 1 to make it viable, so that's disappointing as well. That's really interesting, this. Right, this can still be a 5, which would be 6 and 1, or a 4, which will be 5 and 1. It's definitely looking at that cell. That's interesting. This is either a 3 or a 4. If it's a 4, we're looking at 6, 2. If it's a 3, we're looking at 4, 1. Okay, what about... I don't want to do this. It sees so many blank cells. Let's have a look at this again. And the 5 possibilities, because they might be more constrained than they were a moment ago. If that's a 5, it's looking at those 2 cells. The left one is 2, 3, 4, or 9. The bottom one is 3, 4, or 7. So it could be a 9, 4 pair. Okay, and we'll try this, which is, if that's a 5, it's looking at either 6 or 9 there. And that would require 1 or 4 here. Which is frustrating, because although 1 is impossible, 4 is not. I don't want to spend time trying to figure if I can rule out 3, 4, or 5 here. 3 or 4 anyway, here or here, because there are so many possibilities they're looking at. I think I ought to be doing Sudoku instead, but I don't know what I can do with it. Okay, I'm getting a bit stuck. 9, 1, 8, 6, 7. These digits are again 2, 3, 4, and 5. Which are a popular set. One of those is a 5 on the diagonal. Is that interesting? Doesn't really feel like it is. No, I don't see how I can... Well, okay, if that was a 5, there's no diamond or anything. Oh, well, that would be a 5. There is a diamond here, of course. Ah, and I said this was going to be uninteresting, and I think it's telling us something straight away, isn't it? No, it isn't. No, it isn't. This can be any combination of 3, 4, 5, and that will be fulfilled. Okay, let's look at this 2, just in case. 2 totally blank cells and an 8. I don't know. I don't think that's helping me. Okay, I should look at this. If that was a 4... Okay, I don't think this can be a 3, because it's looking at that, that, and that. And I don't think there's any available differences of 3 between those candidates. Yes, there is. Oh, only 6 and 3, which would break this as a 3. Yes, if this was a 3, that would be 4, and they'd all be even. So that's not a 3. Okay, that's something learned. I mean, it would be... Oh, look, there's a 3, 4 pair. Ah, there we go. That's a 2. And now 2's placed in the central box. That's an 8-9 pair. Now it's Sudoku. Oh, it was Sudoku the whole time. 6, 3, 4, 8, 9, 2. We've got 1, 5, and 7 to place. That gives me 8 there. Okay, I don't know a lot about where 1, 5, 7 go, but I'm learning other things now. These don't have 2's in, so that has come down to just being a 7. And those don't have 7's in. This one can't be a 2 anymore, so that's 8. And we've got a 1, 2 pair. They must be resolved. I just can't see how. Never mind. 3, 4, or 5. Now, can I work on that? Not really. Oh, well, it can't be 4 because that would only be looking at 7 and 8, and they're not 4 apart. So I can begin to look at that. 3 is the easy one. That would be looking at those cells. This one is 3, 4, 5 again, actually, and that maybe that triple in the column is helpful. 3, 4, 5, 9, 2. This is 6 or 7. These are from 1, 6, 7, 8. This can't be 1 anymore. That would be 6 or 7. This would be 1 or 8. And this would be 1, 7 or 8. So not that helpful, but one of those is 4. So if this was a 3, it would be looking at 4, 5, and 2. And that's okay, because 5 and 2 have the necessary difference. If it was 5... it would have an 8 not there, it would have a 1 there, and that would have to be a 6, and that is not going to happen. So that is a 3, and that's not a 3. And now what did I say about 3? It's looking at 4, 5, and 2, so it's going to find a 5 and 2. It doesn't really matter how I resolve those. Now, this is a 2, looking at 7 there, and therefore either 9 here or 5 here. Frustrating. I've got a 4, 5 pair in this column though, so I've got 1 and 6 to place, and they can go in thanks to Sudoku. That 6 makes this a 7. That makes that a 6, and this isn't. That's not a 7. This is now a 1, 8 pair. Oh, I thought that was going to do something. 6 in box 9 is there. Sudoku again. 2, 8, 1, 6, 9. That's not a 7. And that's not a 1, I reckon. In fact, this is... I was going to say this is a 5, 7 pair. I don't have the evidence for that. Okay, this is a Sudoku cell, though. I mean, a diamond cell. And 5 won't work, because it's looking at 6 there and 8 there. So that's a 4. And that's done, because it's now looking at a 5 here. This is now a 3, that's a 4, that's a 3. Let's fill in the numbers and then work out the diamonds. So that 3 is looking at 2, 1, and 4. 1 and 4 have a difference of 3. Success. This 2, we've still got the same problem. This 3 is looking at 6, 2, something, and something. That something is 4, 5, or 7. Let me just fill in those possibilities and get rid of some corner marks. So that 3 is looking at these places and looking for a difference of 3. That's too variable for me. This 4 is looking at these middle bits. I don't know. That 6 is not in play because 2 can't be seen, but... Okay, the 5, we've done that, haven't we? No, we haven't. That's looking at 9 there, and it must now be 4 there, and that's done. Okay, we hadn't done that at all. 8, 2, 4, 1, 6 across the middle. 8, 3, 2, 9, 6. Diagonal, those can't be 4s, they're a 3, 5 pair. Doesn't seem all that helpful. Yeah, hang on, this is a 5 in the row. and that's a 3, and that's a 4. So we're tidying up quite a bit of Sudoku. On the diagonal, this is a 5, that's a 4, this is not a 5. We've got a 2-3 pair left in the box. Those also don't have 5 in, and nor does that. Both diagonals are complete. Now, this 1 is, well, that is interesting, but unfortunately it's fulfilled whatever that is. This 2 is looking at 6 and 8, so it's already fulfilled, doesn't matter what we put in the others. That 3 now is looking at 6, 2, 4 or 7, and I don't think we've achieved a difference of 3 anywhere yet. Seriously, it's quite difficult to check all the possible differences. So we're going to have to use this digit in regard to this 3. And we've got 2, 6 and 4 or 7, and this can't be a 3 anymore. And it's not going to help if it's a 2, because then we've got lots of the same digits. So this is going to have to be a 5, and then it's looking at 5 and 2 for a difference. Right, well that's good. This is now a 3 by Sudoku, that's a 2, that's a 3. That 2 is looking at that cell. I thought it was doing more, and it's not. Okay, looking up the column at the top where those are fixed, this is a trio of 2, 7, 9. 7, I've still got that central 4 to look at, and this 2. Things are getting firmed up here. We've now got 7 and 4. This is going to have to be 9 to make that 2 work. That's handy. Right, so that 2 now works. That's an 8. That's a 1. These projected differences are very interesting indeed. That's a naked 4. This digit is 2 or 9. In the central row, we've got 5, 7, 9 to fill in. And in this row, what have we got? 5, 9, 6, 8, 4. That's not a 9. 1, 2, 3, 7. Now, we've still got this 4, and the 1 has been done. It's got several, well, it's got 2 different necessary differences. This 4 is the last diamond to tick off. It's seeing 6 and 3 and 5 or 9. Now, I'm not achieving a difference of 4 involving those. And therefore, I think this can't be 5. Oh, it could be, actually. One of these is 5, and the other one, 1 or 9, is making the difference. So one of those is 5. That's all I'm learning from that. That's such a strange piece of learning. I think maybe the rest is Sudoku then. This is 1, 3 or 7. I'm going to pencil mark my last few bits. 8, 6, 3, 7, 9, 2, 4. That's 1 or 5. Right, that's forming a 1, 5 pair. So there is only one place for 2 in this row. And then there's only one place for 4. Okay, it is just Sudoku, thank goodness. Because that was going to be a very complicated chain of events to resolve those two, the west compass point and the south one. That's a 7 and that's a 5. This must be known, it's a 1. That's a 7, 5, 9, 2, 3. Brilliant puzzle. Absolutely class. Okay, before I write in that 7, let's work out the 4. Yes, it's now looking at a 5 and 9, so it is done. And this is a 7 instead, and that is a fantastic puzzle. Half an hour of pure pleasure from start to finish. The pedaling pianist has an ability to do that, and I love that he uses his powers for good. Great stuff. Thank you for watching, as always, on the channel, and we hope to see you again soon. Bye for now.